we try to make that system intelligent so that behave like a human being, that take a decision. But this is possible up to some extent, not possible exactly. It can be made that is to be make a system intelligent like a human being. Okay, so I'm going to deliver my talk on CBR based intelligent tutoring system. That means just by this topic, just I try to establish that a teacher can be replaced from your classroom with the help of a tutor, and tutor is a system. That means your computer, and means your computer can take charge of a teacher. Then how we make it? So before that, we have to discuss. Topic is a CBR based intelligent tutoring system for e-learning. As you are aware, e-learning is a new educational concept. Now this is not a new. Most of the universities and most of the colleges are using this concept right now, but through which we can deliver lectures and we can provide the course content to the student with the help of system, and it provides a learner-oriented environment. Learner-oriented environment means exactly what you want. You can discuss your problem with the teacher, but in the terms or in the case of a teacher, in the absence of a teacher, where you interacting with the system, how you interact with the system. So the main emphasis of this intelligent system based CBR based ideas, exactly the student interact with the system and system behave based on the requirement of the students. So basically this e-learning word became a buzzword in 90s, and as I said earlier, now majority of the universities and colleges uses this particular course content or course materials that is basically we use in a e-learning environment. So this becomes a necessity. Let us suppose you want to attend your lectures from MIT or some. Let us suppose I take example. There are you want to attend any MIT, then how can you attend? First, you have to select courses from MIT online, and thereafter they provide such environment through which you can attend the lectures online, maybe through Moodles or some other tools, and thereafter after a certain learnings you can part of examination of that particular university like MIT, and thereafter you just that university examine your learnings online and you will get your degree. So you are here and you are getting your degree from the foreign university or somewhere else. This is the one benefit of that online learning. So these are the certain benefits. These are remote location learners. This will help in this. Learning time constraints. Let us suppose you want to learn in the evening hours, but your college is available in the daytime. So in that case, you cannot learn that particular lesson. So this is again a constraints. So online learning provides this kind of facility. Cost of the learning, you are unable to attend or you cannot bear the cost of a particular lecture. In that case, you can learn this thing online. And specialized trainings. Let us suppose, as I given my example, if you want to attend a particular course from the MIT and you are unable to attend that one, but online or through e-learning you can attend this course. And this is an individualized learning. As the pace of the student, as the requirement of the student, you can get this particular course or content effective than the classroom learnings. Means you have a lot of examples available through online, and this is very complicated economic limitations associated with this one. So this becomes very this have a very short history, but becomes a very popular this course e-learning. So basically this objective of this research is what? We want to develop a distributed case-based switching based intelligent tutoring system exactly what is the case-based reasoning I am coming later on. So we want to develop a CBR-based ideas, and that will provide the individualized learning environment that is comparable to one-to-one human interaction. Let us suppose you want to interact with your teacher, but within a class you have a 40 or a 50 student strength, so you cannot interact one-to-one. Okay, but this kind of learning provides a one-to-one interactions. So this system which we develop that identify the learner's individual needs for learning, and thereafter this is responsive to individual student needs, exactly what a student wants, and thereafter it provides individualized instructions. As let us suppose we have a three category of student. One is a brilliant student, average student, and poor student. So as per the need of the student, let us suppose the poor student needs a more example as compared to the intelligent student. So this system provides these kind of things, and this is the intelligence of this particular part, and this is easy to use. This provides also feedback to the students and must encourage active participation during learning. Fine. So these are the things which incorporate this within the system, and basically within this presentation I will stress upon the requirement of the system, necessity for open distance learning, and what are the basically CBR and how this is mapped with the intelligent tutoring system, and this is the thereafter we have to discuss with the architecture of CBR based ideas. So first thing is, what is CBR? Case based reasoning. Basically this is the AI methodology, well known AI methodology, and this models a human reasoning and thinking. And this is used for building intelligent computer systems. Basically within a CBR, case-based reasoning, like a human being, at the time of our learning, what we did? First, this is a question for you. At the learning phase, what we do? We just recall our previous experience. We want to solve any problem. For that purpose, we have to recall our previous experience, how we come out with this particular situation. Then whatever previous experience we have, based on that we solve a new problem. The same mechanism we use for within the CBR. So within this approach, we store our previous experience in memory as a case, and solve based on these cases we solve the new problems. And within that, these are the different phases that retrieve the similar experience about the similar situation from the memory. Reuse the experience in the context of a new situation, store new experience in the memory as a learning. And this is like a human being. Human being is use the same experience, whatever experience we get from the environment or from the outside, we learn as it is. The same way here, whatever new experience we have, that is stored. So this is the problem solving in CBR. Basically this is, sorry. Within this, these are the problem spaces, these are the corresponding solution spaces. Let us suppose these are the problem 1, problem 2, problem 3, problem 4, problem 5. So corresponding, please switch off the slide please. So let us suppose these are the problem space and corresponding solution is this one. And now we want to solve for another problem. This is a new problem for me and I want to solve. So corresponding solution space is this. So my solution is reside between these solution spaces. So for this problem, I have to identify in place of this or this, I have to identify that my X will be the new solution and that will be in between here. So for new problem that can be solved from the retrieve a similar problem. For this problem we have a solution this. So for this problem we have a new solution. So that is very close to the earlier problem, and whatever solution we get from this solution space, that is adapted from or we retrieve from the solution space. Basically within a CBR there is a certain components. First thing, within a case-based reasoning there is a knowledge, and another one is the CBR cycle. Within a knowledge we have certain things, that is a vocabulary. Vocabulary container that contains terms related to that particular knowledge, and thereafter we have a similarity matrix. Within this similarity matrix we have similarity spaces. What are the similarities we have in the solution spaces? These similarities stored over here, and thereafter we have a reasoning. Why this selection or why this solution is to be selected? So that is a part of the reasoning, and thereafter the case base, that is solution, and this is a CPR cycle. Within this we have first one is the presentation, and thereafter we retrieve a new solution from the new problem, and thereafter this solution is stored in the case base. This is used for a new problem. Then this solution is reused, and thereafter whenever this solution is used and that is any similar solution is there, then that is retrieved from the knowledge base, and this is a part of reuse, and that solution can be quite similar that we have earlier. So this is the cycle of CPR. So by applying this case-based reasoning, we try to solve our problem for e-learning. So I am taking one more example for CPR to understand this. Let us suppose we have one problem which we want to solve. What is that problem? Within my car, brake light is fused. Let us suppose that is not working, and car is this one, that is the manufacturer in this year, and battery voltage is this, and state of light is okay. Now why this particular light is why not this is working? These are the symptoms. So to solve this problem, what is the problem behind this? So we have these are the features, means the problem, car, year, and this, and these are the value. Problem is what? Brake light doesn't work. So we try to retrieve these kind of problem from the case base first, and when we get the similar case from the case base, we try to retrieve a solution of that problem for this problem and reuse the solution. If the similarity is quite similar this solution, then this solution is used for my new problem. Please try to understand. This is my problem, and I want to solve this problem. Why the brake light doesn't work? For this solving this problem, I try to identify the case from the case base. Case base, within that we have some similarity matrix or similarity parameters. Based on that, we try to identify the similar case from the case base. The case having the same parameters used for a new problem. If the parameter, then that can be applied for the newer problem, and whatever solution for this problem can be used for this one, and by this way we can solve the problem. So this is the mechanism of solving a problem in CPR. So first of all, whatever problem we have, the same problem this is the case one, that is already stored in the case base. So within this is the back light doesn't work, within this front light doesn't work. Car is whatever manufacturer, this is a new another car, and the year of manufacturing is some whatever that is there. Then battery voltage is there, here is there, and the state of light is okay, and the state of light is again okay, and there is one more parameter or one more feature is there. The state of light switch is also okay. And what is the solution of diagnosed front light fuse? Means light is okay, voltage is okay, every their switch is okay, but again your light doesn't work. In that means you have to check the fuse, and the solution is what? This is the diagnosis, and the repair is what? Replace the front light fuse. So how within this we have 6 different important features, and they have their own weights. So important features are 6, less important feature is 1, and let us suppose we have within 20 cases within the case base. So we have taken a weighted average of all. So within this, the features multiplied by 6, this multiplied by 6, this is multiplied by 6, this is again multiplied by 6, and we calculate the weighted average of this. Fine. This is my case 1. Now I'll go for another case. This is my case 2. This is my problem case. This is my case 2. Now we just check. Here the weighted average for the similarity case is 0.86, and in the another case this is what? This is a 0.58. So this is very less than the earlier one. So whatever we have some part of artificial intelligence, some is a cognitive science, some other part is education, and fourth one is HCI, human computer interaction. And based on all 4 fields, the hybrid knowledge or hybrid system becomes ideas. And the aim of this ideas is create a computer-based tools that support the individual learners. And this is work autonomously, intelligently, means exactly work on its own nature. So this is the part, this is a formal definition of ideas, and the working of ideas when any user interact with the system, then in between a system and user there is a user interface. User interface interact with the system. Within the system we have a student model, teaching strategies through which we provide the content to the student, and knowledge domain which stores the knowledge related to the content and related to the student. So when a student interact with the help of a user interface to the system, the student gets the appropriate content from the system with the help of ideas. This is Bloom's taxonomy, which help us and which tells us, okay, let us suppose this is the classroom is this graph indicates this is a learning process, and this is a type of learning. So within the classroom learning, and this is the individual learning. Means let us suppose the 40 students within the class, and this is one student interacting with the teacher. So this is individualized learning is more effective than the classroom teaching. But when we introduce intelligent tutoring system, in that case, this is the classroom teaching, this is the individualized learning, and this is what? Learning through an intelligent tutoring system. So this is more effective than the classroom teaching, but this is less effective than the individualized learning. But again, this is a good chance through which we can get the good learning scopes. So within the CBR based ideas, used to represent a student model, and domain knowledge in form of cases in the ideas means every student treated as a case, their learning behavior, their emotional states, their type of learning, whatever. So these are considered as an individual student considered as a case, and that cases are produced by the learner and experienced by the other learners and developed by the human tutor. Earlier the means when teacher interact with the student, whatever experience get by the tutor, that is stored in the ideas, and that is used over here. Means the experience of other learners are developed by the human tutor, that is on demand if system fails to provide appropriate scope of teaching. And these cases can be used to train the tutoring system for a particular user. And CBR based ideas maintains a learner's profile, means individual student's profile, exactly what he or she learned or what is the previous learnings, and maintains a demographic data, means earlier the student registered from which locations and now the student registered from which location. So this is the demographic data, and maintains the course contents, exactly till date, how much that particular student learned and what is the next one, and maintain the performance of the student based on the test. Exactly, let us suppose that 3 or 4 tests already conducted, so what is the performance that is already stored, that means that is stored within this. and stores a dialogue history, means a tutor as well as a student, and that also stores a metacognitive abilities, means the way of learning or emotional states, and it provides a personalized teaching by acquisition of learner knowledge and diagnose the learner's approach, exactly what drawbacks in teaching, so that can be diagnosed, and it provides a feedback and advice. The system will provide. So within the cases which we store within CBR based ideas, so the cases, these are the type of cases, mean the situations, in which situation you are teaching to the student or a learner situation of the learning. What are the solutions available, what are the outcomes, what are the performance. Within the situation, maybe a student static profile, a student a dynamic profile or instruction, etc. And the solutions means the characteristics of next appropriate examples or exercise, exactly what you have. And outcomes means use case history, exactly that case that is stored in the case base, how many times that is used. And performance means difference between the expected behavior and observed behavior, exactly what you expecting from the system, how much student learn, but actually how much you get. That's the part of this. So these are the cases which we store in the intelligent based CBR based ideas. These are the case explorer through which we get the cases. These are the different cases, case 1, case 2, case 3, and these are the different parameters within our case base. This is the problem with the case 1, this is with the case 2, similarly from a case 3. And this is the one type of cases. This is another cases, that is a course case, means our individual subject treated or as a case structure. And this is the tutor case. Within that again the same different fields. And these are the procedures for a case matching, means how to match the cases. So within that matching for a cases there is a features, and whatever features is there any? So we try to identify the exactly whatever features we have in the case base, and for a new problem what features are matched. So that is matched with this particular procedure. And basically this is how we retrieve the cases from the case base based on the similarity. So this is the particular algorithm, you can say. Compare a new problem case with each case in the case base. Select feature depends on the feature value. That means we have to get the weighted value of that one, and based on the highest weight we consider that case is more similar to that. And based on the more similarity you get the case. So this is the particular flow diagram of this one. So this is the problem input. This is the case retrieved based on the similarity matrix, and this is received from the case library. This is case adaptation, and this is the method that is applied on this one, and you get the particular solution, means more similar cases on that. Yeah, here there is two things. One is the source case, in another one is the target case. So source case is what exactly within that is available in database, and target case is stored in the new case, means target case is that case which we are trying to solve, and for that purpose we try to finding that solution. So that is what target case, and source case through which we try to solve that particular case. And for this, these are the similarity measures. Basically these are the different source cases. Let us suppose this is a time oblique the source cases, and these are the again a source cases, and source case 1, this is the source case 2, and based on the next with this particular equation we just try to identify this equation I use in my earlier example of that. So based on that we just try to compute the similarity, and when similarity is highest, then that case can be used for that particular case is used as a solution case. So let us suppose this is the case 1, case 2, let us suppose, and this is the case 3. Now, similarity of a new case is with the case 1. This is indicated by this one. This is my new case, and this gives the equation of what? Similarity of a new case with case 2, and this gives what? Similarity of new case with the case 3. So which one is the nearest with the new case with the existing case that can be used as a similarity? So this is depicted over here based on the equations, and these are some algorithms which we use for the case matching in distributed environment. And this is the retrieval of cases from a case base in a distributed environment which we applied. I think this is, I have to skip this one. These are the different algorithms which we use for retrieving cases from the case bases based on the different parameter, on different features which we use. These are the different parameters within my case, and these are the description of the cases, and these are the solution parameters. And within this architecture, this is the general purpose architecture of distributed CBR based ideas, and this is the network architecture, and this is the agent architecture. In my work, I use different agents for making a process more effective. So within my case, I have a personal agent that will maintain, that will profile of a particular student and a particular tutor, that will maintain the profile of a particular case. And similarly, another one is agent is a teaching agent. Teaching agent identifies the status of the students, exactly how much that particular student has learned, or what is the status of that. So these are the different agents within my system, and these are the different methods I use for selecting appropriate exercise, for appropriate course contents. I am skipping except few, all are students, so this is not your, I think, I'm sorry, but I am skipping this one. So these are these, and after this, within this prototype, these are the results. This is the earlier part, the pre-learning performance. If we select 20 students in two groups, so this is the pre-learning, means these are the classroom teaching, and this is what after IDS learning. So you can easily visualize the results are improved. So ITS is more effective. Intelligent tutoring system is more effective than the classroom teaching, but definitely I agree this is less effective than the individualized learning with the human interaction. Basically, these are the conclusions and relevance in the current scenario. Basically, individualized tutoring is provides a flexibility in teaching, and this provides tailored instruction and recommendation as per student's need, and this facilitates a motivation to the students, and this is a cost effective, easy to handle, and it will be treated as a learning management system. Already we have a lot of learning management systems available in the market, but this is there, and even we can improve the efficiency of this one within the LMS or the CMS. Still there are certain features still missing. So if we use these features with LMS and CMS, then we can improve the efficiency of these two tools. So within that, if we incorporate these features within my ideas, means online discussion, wikis, online quiz, blogs, blackboards, campus chart, reports, assignments, etc., then this system can behave more effective than the CMS and LMS. And it will be converted into a mobile application or a mobile platform using AHG cloud. In the earlier session, you go through the cloud. So this can be used for a cloud environment. So you can access your class within your mobiles or your handhelds. These are having a certain limitations. Means for developing a such expertise system require a group of experts. Within that, you have an ITS administrator, content writer, domain expert, knowledge expert, and all these are there's a problem with incorporating all the people for a single system, but we can do that and require additional hardware support to implement it for your system. These are the limitations in my case, and there are currently some universities using certain ITSs with the improved technology. For example, Indiana University using own course. This is the name of the ITS. MIT using a Salar, Stanford using a Courseware, Cambridge Mellon using Actar, or these are the different ITS which most of the university using. Similarly, with the Indian context, Shikshak is developed and used by IIT Kharagpur. This is developed already. And Marathi Tutor and Acharya, these are both the tutors developed by the CDAC Mumbai. And so many more are ITS available in Indian and international level. Thank you very much. Any questions, please? Any query, please? After post lunch, this is sleep time. But I had a lecture and this is a boring lecture. Anyway, please. हाँ, देखिए, पहली चीज है आपको एक तो नॉलेज बेस क्रिएट करना पड़ता है. जैसे आपका अपने ब्रेन है, in the meat machine. This is your brain, and this is known as a meat machine. Why this is known as a meat machine? I just spoke first, then thereafter giving your answer. You provide a certain input to your brain. Your brain process based on the input, and you have a certain rules within your mind, and you will get a certain output. This brain is behaving like a machine. That's why this is known as a meat machine. So, in your brain case, exactly what you are doing. How you are making your make yourself as intelligent like others. You are giving more and more information to you. You are learning more and more information from the environment, from the book or somewhere else. So you are making intelligent. The same way, first of all, for any intelligent system, you have to create a good knowledge base for that system. That means outer information, environmental information related to a particular domain. And thereafter you have a set of rules which can be applicable for that particular domain. When this knowledge and rules, means rules applied on the knowledge, and for a certain input you perform a certain reasoning, you will get a certain output. So what is this? These are the intelligent behavior. Yes. So within this, exactly we are doing. You can understand this mechanism like a human intelligence. एक छोटा बच्चा होता है, वो छोटा बच्चा कैसे सीखता है? आसपास से सीखता है, वो अपने मदर फादर से सीखता है. So exactly what is the mechanism of that? Continuously watching the things, continuously observing the things, continuously getting the information from the outer environment, and thereafter storing inside the brain and processing it, getting the information. Don't do it. Means these are the instructions which get from the teachers, from the mother and father. This is the correct, this is the wrong. So this is verified fact that becomes a knowledge base for that particular child. Similarly, you have to store the outside words input, means in terms of information that is stored, that is verified, that becomes a knowledge, and for a particular environment you use it.
Sir, नॉलेज तो बहुत मिलती है हम लोगों को एनवायरनमेंट से, सराउंडिंग से, अपने आसपास से, लेकिन मशीन को फिर इतना कैपेबल बनाना पड़ेगा कि वो भी एनवायरनमेंट से सीखे.
यहाँ पे आपसे जैसा कहा ना कि एक एग्जांपल मैंने जो दिया था, उस एग्जांपल में यही था कि एक कार का प्रॉब्लम था, है ना. एक प्रॉब्लम था, उस प्रॉब्लम से सॉल्यूशन दो केसेस मेरे पास स्टोर थे. एक नया केस आया, और नया केस आया, उन दोनों केसेस से जो भी सिमिलर था उसका सॉल्यूशन उसके लिए अडॉप्ट किया. पार्शियल था, फुल्ली था, दैट इज डिफरेंट, बट दैट इज स्टोर्ड. अब तीसरा भी क्या हो गया, एक नया केस और स्टोर हो गया. तो दैट इज व्हाट, दैट इज द लर्निंग ऑफ द सिस्टम. योर कंप्यूटर अडैप्टिंग दिस थिंग. Means continuously adding the information within the knowledge base. Whatever you are, means your computer getting whatever information from the outside, that is stored in the knowledge base. And based on the, maybe on the base of the interaction with the human or based on the another reasoning, that will verify it and use it for the future.
Solve a new problem and based on that available cases that we have been stored in our memory.
Yes.
Sir, but इसके लिए हमें प्रोग्रामिंग करनी पड़ेगी.
जी हाँ. You are free. Normally AI के लिए जो प्रोग्रामिंग लैंग्वेजेस होती हैं वो होती हैं Lisp and Prolog. But you are free. There are lot of interfaces available through which you can program and you can use that program.
ये भी पॉसिबल है कि मशीन अपने आसपास के एनवायरनमेंट से सीख के डेटा कलेक्ट करके अपनी मेमोरी में स्टोर करे.
That can be captured from the sensors. Continuously sensors work on that. That will capture the data from the environment. There are various need to be associated with that particular system. That can be, for example, let us suppose we want to capture the emotion of a human being. That is a part of emotional intelligence. For that purpose, what we have to do? We have to continuously monitor the various people's and emotions of that. Exactly what kind of facial expression they have, what are the eyeless behavior, what is the length and different dimensions of the face. So continuously capture the data and you just say in this particular case this is a sad, in this particular case this is a happy, this is a normal, this is stored, and thereafter continuously that your machine or the system monitor your behavior, and whenever you use this knowledge can be used whenever you require for a particular another instance. Any more questions? तभी तो मैंने आपसे आते आते पहले कहा था सवाल कि when you are intelligent enough, then why you learn artificial intelligence? Basically, the purpose behind is that we want to make our system like a human being. The same procedure we want to adapt of learning which we have in humans. So the same learning procedure, AI try to attempt whatever mechanism you have of learning in humans, that can be imposed or that can be used for the machines. Anything else?
Any other question from audience? Thank you, sir, for sharing your deep knowledge about CBR-based intelligence systems of learning. Now, I request to the youngest selected for oral presentation to contact to Ms. Karuna Yadav in the green room. Mr. Ashish Soni, Ms. Mansi Sharma, Ms. Ashima Bhutna and Harshita Sharma. Please contact to Karuna ma'am. Now let me move to the next speaker, Professor Madhvi Sinham. She has also spent valuable years in research area of artificial intelligence, language computing, algorithms and soft computing applications. She has completed her MSc in Computer Science from Banasli Vidyapeeth in 1990 and awarded by PhD degree in Computer Science by Banasli Vidyapeeth in 1998. She started her career as lecturer in Computer Science from Banasli Vidyapeeth in 1990 and now she is Associate Professor in Department of Computer Science and Engineering, Birla Institute of Technology, Jaipur campus. So let me have the privilege to listening the experienced word of Professor Madhvi Sinham. I request to Professor Madhvi Sinham to grace the dais. So the topic machine translation. But before coming to this topic, I would like to give you the background for what we were discussing, how to make computer intelligent. Because this is one of the application of artificial intelligence. When we are saying that we are making computer intelligent, so first we should define what is intelligence. Basically, it is very difficult to characterize the intelligence, but we can try by saying that if we have a knowledge, but only knowledge cannot make you intelligent. So making a correct inference in correct time, in limited time is also important. Let's take an example of chess. Most of us have the knowledge of what are the possible moves. So this is a knowledge. What are the possible moves in a particular situation. But in a particular situation, which move can lead us to the winning situation is the inference mechanism. Okay? And that too in a limited time. Because when we are taking a decision, there are a number of rules which we can apply. We can take another example of medical sciences, where doctor is having a lot of knowledge about the diseases. If these are the symptoms, then this is the disease. Most of us are from the computer science background and we are aware about the different searching algorithms. Naturally, these type of searching algorithms cannot be used in situation if patient is not having this disease and patient is not having this disease. That's why patient is having X disease. Basically, in this case, a different kind of search techniques which are called heuristic searching, where some kind of intelligence is used, which we mostly apply in gameplay. When we are playing the game of tic-tac-toe, cross zero, then you want to explore all the possible moves where you can put your cross or zero. I think everybody is aware about tic-tac-toe game. You can find out which move can lead to the winning situation. So intelligence means one thing is the knowledge, second thing making a correct inference from the knowledge, and in particular domain, not on every application, how we interact is also important thing. How we interact means, suppose I am giving this lecture in Russian or a language which you cannot understand. So I may be having a knowledge, I may be having a capability of making an inference, but I am not able to communicate you. So then this knowledge and that intelligence has a no use. So these are the three important things. One is the knowledge, inference and communication. Now that when we talk about the communication, then when you are developing your applications, application means either in C language or Java language, then you are using the symbols of English language. But every one of you understand that computer does not understand Hindi or English or any other alphabet. Computer is language. And we use the translators which convert your program into the machine language. And these translators are compiler or interpreter. Okay, so when we are talking about the machine translation, only the difference is in the source language and the target language. When you are talking about the compiler, then we say the source language is programming language and the target language is some object. This is the case with the interpreter. But in case of the machine translation, what we are saying that the input is natural language and the output is also natural language. Naturally, the question comes, then what's the big deal? When there is a compiler which can convert your high-level language program into machine language, then converting the English sentence into a Hindi sentence or vice versa or different pairs of language, what's the big deal? Is it a big deal or not a big deal? Because you might be using some online translators. What is your feedback? Translation. Translator, feedback is the translator quality, the output. The quality of that means whether it's a perfect output or you need some post editing. Post editing.
error. They are with the 100% accuracy. Your program executes by your machine when you use the compilers and interpreters. So what we are discussing, what are the problems when we are dealing with the natural language? Why it is not so well defined that we can convert one natural language to another natural language. Okay? So this is my topic. And naturally when we are dealing with the two languages, then I am not specifying that we are dealing with English to Hindi or Hindi to English. When we are talking about natural language, then it can be any pair of natural language. And we all know that computer understands only a language of binary. So there is no restriction on us to write the code in C language only using the English alphabets. You can write down your own compiler with using the Hindi alphabets. Computer does not understand if. You can also write down yadi. But what you need? You need a program which can convert your yadi and if into the equivalent code. Okay, so we just give the formal definition of intelligence. Actually, that has been covered by Dr. Aritificial, so I can skip it. And why we are calling it artificial intelligence? Because humans are biologically intelligent. It means whenever we are saying we are having a knowledge, then we are not having a button which says that add this thing. But in case of the computer, it's not just the addition of a new knowledge. Because whenever we are dealing with a lot of information, then we use our knowledge, intelligence. How to add this knowledge into our knowledge base. Why? Suppose you read some word, but you don't understand the meaning of that word, or you heard some word. Then mostly what we do? We use that word, we get the feedback, whether we have used it correctly or not. If we have used correctly, then whatever we are information or knowledge about that word will be added. But if suppose most of the time you can do this thing with the children. They are using some absurd word, then you will say, no, don't use this word. So they will understand, oh, this is not a good word, we should not use. So whenever we are updating the knowledge, then knowledge updation is also an intelligent process. It's not that we heard, suppose I told you 2 plus 4 is 6 to a small child. Then okay, 2 plus 4 is 6. Another senior student or some guy came to him or her and said 2 plus 4 is not 6, 2 plus 4 is 7. Then it's an inconsistent knowledge. So child will use her knowledge, her or his knowledge or intelligence, which one is correct. Because 2 plus 4 can either be 6 or it can be 7. It is not possible, it can be 6 and 7 both. So the source of the information by which you are getting the information is also important. Because dealing with the language, again the knowledge is not static. We almost say that these are the valid words now. The words which we use in SMS and mail, they are also valid words. They are included in the Oxford Dictionary. So now they are valid. So even the words are not static. These are the list of words which we can use in the sentences. The words is also changing. So the knowledge is always changing, but the source of knowledge is also important. And since computer is not intelligent by its mechanical devices, we are putting the intelligence by the programming or by some other methods also. So we call it artificial. Here I will take an example of one TV show, Small Wonder. Have you seen it?
Yes.
That's a very good example of AI, artificial intelligence, the robot. And to the example, it's a very good example of how computer interpret. Because whenever we are saying something, it has multiple meanings. Suppose I say person is sleeping and हमने बोला उठा के लाओ. It means उठा के लाओ doesn't mean physically. So if you have seen that serial and the other serials also in the channels, then you can very well understand what is natural language processing and why it is difficult. That is the main problem of the machine translation. Basically, machine translation is an application of one of the application areas of AI. As we have discussed, AI has a very vast application area. It's not limited to a particular area. When we are saying making a computer as intelligent as human being, then naturally there are a lot of things human can do which computer cannot. At present also, with the same perfection. Visualize the thing. We can take the spoken signals also. Basically, we can interpret many languages, not only the textual language. When you are sitting in front of me, then some of you are not saying anything, but still I can interpret what they mean to say. Okay, so language is not limited to the textual or spoken signals. It's a mode of communication, language. But the mode of communication means by which we can say something. But whenever we are dealing with the computer, we have to be very strict. We have to be very strict means what word we have to use in which sequence, which we call a syntax. It's very important. We should write down the complete syntax of a sentence. If you miss the semicolon, then you will get the error, which is not the case with the human interaction. When we are interacting, then most of the time we may be grammatically incorrect. Even we may be using incomplete sentences, but still we can interpret. We are using pronouns, and you can interpret it okay. What does it mean? So, he or she uses of pronouns, then you can interpret the he is used for which one and she, it, whatever the pronoun words. But in case of the programming language, that is not possible. So, these are the two things which are related to the natural language processing, which is one of the application area of intelligent system. As I have told you, like vision, speech, images, even the search, how to search in a very large domain of knowledge, also an intelligent method for it, heuristic which we have discussed. Natural language processing means we are not working with particular syntax language, programming language, but we can communicate with natural language. That means language. It may be Hindi, English, Russian, Japanese, any language. Now in this natural language processing there are two things. One is the understanding. It means user can input his or her query or information in natural language, which is not possible in most of the applications. We are using GUI applications, graphical user interface. You just click, you select it. You are using your learning system. Most of the time evaluation is based on objective type questions. Objective type questions whose answer is multiple choice ho, yes, no, ho, one word ho. But if you want to get some sentence as an input, then program cannot interpret it. What do you need to say by this thing? So understanding means user can input something into natural language. And generation means whatever computer is communicating to the user is in natural language. Whenever you are writing down printf double quotes with something, that is not a natural language generation, because you know it. Every time it will give the same thing. You must be writing your programs, you are using some printf in double quotes, then every time element not found, then it will write down element not found, element not found. But if you are working with some human being, then every time you won't say a same sentence. For the same situation, we may generate a different sentences. So natural language generation is your communication from computer is in natural language. And machine translation is the application of both understanding and generation. These are some application areas of NLP, but we will be discussing on machine translation. And we have seen why it is difficult to work on natural language as compared to the programming language. So all of you are familiar with any one of the programming language, and you know it. Programming languages are well defined. It means there is no ambiguity. Everything has only one meaning. Your variable declaration, your statements, everything has only one meaning. If you have certain ways to describe more than one meaning, then we have the set of rules which will map to the one meaning. For example, I'll take an example of inheritance and etc. If you have used these languages. So if you have more than one meaning or overloading and all that thing, but we have the set of rules to the only one meaning, which is not possible with natural language. I'm not taking an example of any language, but you can see this, whether we are talking about English or whether we are talking about Hindi or any other language of your knowledge. So in programming languages, there is no ambiguity, there is well-definedness, which lacks in natural language. So when we are saying translators, when human translator exists, it translates one natural language to another language. Through machine translation, what we want a program. We want a software which should convert or we should translate your source sentence into, not a sentence, source text into the target text. It means the knowledge of the source, suppose I am saying it translate English sentence into Hindi sentence. Then, being a translator, you should have the knowledge of English language as well as the Hindi language. It is not possible that by knowing English language only you can translate it into Hindi. So knowledge of both the languages, source and target, is required. When we are saying knowledge, then what are the different levels of knowledge which is required? Okay, this is fine. This is an example of previous machine translation system. This gives an example that when an English sentence is converted into Russian and back to English, how the sentence has been changed. Because now we can find out some reasons why the sentence, the original sentence is the spirit is willing but the flesh is weak. It is translated into Russian using some program. From Russian back to the English and the sentence converted into the liquor is good but the meat is spoiled. We understand this thing. We can understand this thing why the change has been occurred because of the synonym words. Because spirit is also alcohol. Spirit is also alcohol word, no? There are number of synonyms and synonyms words are there. But we have to see in which context which word has to be used. So this is an example of error of machine translation system. How it converts the meaning. So what we want? We want to reduce this error. Presently there is no translation system with 100% accuracy. Every system has some kind of accuracy and up to 90 or 91% accuracy is very good systems. And what I want to add, in intelligent system, whether it's a machine translation or anything, the domain or the area for which application has to be developed is always limited. Otherwise, your knowledge will be very vast. You cannot write down, the project cannot be completed in a defined period. If I say write down a machine translation system for English to Hindi, for every type of sentence, then your dictionary will be very large. The type of sentences will be very large. But if we restrict the domain, suppose we say, okay, write down the translation for the sentences or the communication which is occurring in the educational systems. If we limit it, then we may achieve the goal. Through the websites and explore the work which is done by the Indian scientists in the field of machine translation, then you will see that for Rajya Sabha we have a translation system. We won't say that same system will work for the other domain also. We have for the tourism department, you can explore the websites of IIT Mumbai, CDEC Pune, CDEC Noida. They are working in this field. And it's a very emerging area where every one of us can contribute because we have certain knowledge about the languages. Now I would like just to give a brief idea at what level language has to be analyzed for the translation. Suppose I give you one sentence. I am speaking on intelligent system, and I ask you to translate it into Hindi. Then, if you are aware about the compiler also, then you know it that the first step, meaningful words are separated. Meaningful word means I, giving, talk, on, intelligent systems. So this is the work of morphology. Phonology we can skip this because this is related to the speech. Because in speech, finding out the word is a separate thing. We can concentrate on written text. So first we have to find out the word. But the problem with the natural language is this. Suppose I say I am talking on. Now talking is a one word. Talking is one word, but in the dictionary we won't have the talking word. We will be having a word talk. And with certain set of rules we can derive this word talking, which may change the meaning or category of the word. This is important thing. In case of the programming language, if you are using temp, then temp is one word. But in case of natural language, we are having variation of the words. Number, you use prefix, suffix to form the words. But in dictionary, we are having a root word. How to derive a word from the root word and associate the correct meaning of the word. That's a morphology. After that, the important thing is whether the sentence is syntactically correct or not. Does it really requires that in machine translation, input sentence should be syntactically correct?
No. This is not.
No. Because in this case, our aim is the meaning of the input sentence should be communicated in a translation. So if we have the incorrect sentence also, then we may accept it. Because meaning should be communicated. But syntax will give you what are the objects, which are the verbs of the sentence to map to the object level. Second comes semantics. What is the meaning of the sentence? In programming languages, we stop here. What is the meaning of the sentence? C is equal to A plus B means A and B should be added and result should be stored in C. But in case of natural languages, semantics means word meaning. But the actual meaning may be different. Suppose I say it's very hot here. Or suppose I say it's very chill here. Then it doesn't mean I want to say only it's a very temperature is very low. It may be possible that I want to say that control the temperature of the AC. The action I want may be different. The actual meaning may be different. So in natural language, one thing is the word meaning, which can be designed with some rules. But the second thing is the pragmatic, which is the actual meaning of the sentence. And again it requires lot of knowledge. Because the context where the sentence is used, who is saying the sentence is also important. To whom the sentence is told is also important. So all that kind of knowledge is required to get the actual meaning of the sentence. And then after that, the same process, this we can leave, the same process will be done for the target language. But there is no one-to-one mapping. Suppose I say, I am talking on intelligent system. I can write it down. I के लिए the Hindi word is there. मैं. M. Now M, there is no one-to-one correspondence between English and Hindi. One thing is that there is no equal words for a target language. Then in source language, the grammar rules may be different, and for the target language, the grammar rules are different. Where the verb comes, where the object comes, they are two different things. So the conversion of source language to object language is also troublesome. So these are some challenges which are in the machine translation. Okay? And to overcome these challenges, what is done? One thing is that domain is restricted, because in most of the cases in natural languages, most of the words are multiple meaning words. Words is not having a single meaning. They are having more than one meaning. For example, bank. Bank may be used as a river bank or may be used as a financial organization. Suppose we are saying that our machine translation system is for tourism. Then the maximum possibility is that the bank is used as a river. So there are a number of methods, intelligent procedures by which actual meaning of a word is assigned in case of the ambiguities. Statistical analysis can be done, rule-based system can be done, example-based system can be done. Example-based, a lot of sentences are stored already with the system, and from these sentences actual meaning is written. Statistical, if this word comes before this and that, then what is the probability that word is having that meaning? So kind of that modeling can be done. Okay? And then in the target language, the sentences are generated and then they are checked whether they are syntactically correct or not. Okay, so natural machine translation is a very challenging task because of the ambiguities. And to overcome these problems, there are certain methods which we can apply, which are based on knowledge, inferences, and other things. And any question?
Now session is open for interaction. Any query from audience?
My is that is better than
Human intelligence is better.
then why are you going for artificial intelligence?
Human experts are not easily available. Okay? As we are talking about the e-learning systems, then individualized learning is the best. Okay? Is it fine or not? Individualized learning हमने आपको डिस्कस किया था ना सब में. Individualized learning means कि अगर आपको एक टीचर पढ़ा रहा है, सेकंड को दूसरा, थर्ड को तीसरा, then that is the best scenario for the teaching learning environment. But what is practically done? Practically क्या होता है? 1 to 40, 1 to 50 के रेशियो में पढ़ाई होती है. तो this is a middle way. कि हमारे पास में जो human scarcity है, हर फील्ड के experts नहीं है ना available. उनको या तो हम approach नहीं कर पा रहे हैं, maybe any reason, physically available है, maybe very costly. उस scarcity को reduce करने के लिए intelligent system है. They are not to replace the human. Again, I will give you an example of movies. Star Wars देखी होगी, देखी होगी ना? ये देखी तो देखना, बस पढ़ना. अगर totally आपने machine पे, क्या intelligent machine है, चाहे वो dumb machine, अगर society machine controlled होगी तो क्या होगा? क्या होगा बताओ?
Machine will control the society.
Machine will control the society, then what will happen? The society will collapse. There is no place for the emotions. There is no individual binding. It's not that the intelligent systems are the systems which are going to replace the human beings, but they will assist the human beings. It may be possible I am not good in mathematics. I know mathematics, but I am not good. So with the intelligent system, I can teach properly.
Good afternoon, ma'am. In the very first scenario we are discussing, when somebody learns, you are given the example 2 plus 2 is equal to 4, but someone tells 2 plus 2 is equal to 5, something like that. Then if we enable the machine analyze the knowledge before getting it, so will this not be so okay?
Analyze means how?
How means suppose somebody tells me 2 plus 2 is equal to 5, but I know 2 plus 2 is equal to 4.
I means what? Machine?
Me machine.
Yes, ma'am. Yes, ma'am. Yes. Okay. Means first of all, machine already knows 2 plus 2 is equal to 4, but again we are telling it 2 plus 2 is equal to 5. This is the case.
Who is telling? It's an important thing.
Anybody among?
Whenever the knowledge is updated to a person, then you always verify who is saying this. Isn't it? Or you will add that knowledge depending on anyone.
But ma'am, by mistake.
Suppose by mistake means?
Sometimes it may happen if I rely somebody the source of knowledge that can give me correct knowledge. However, it might be possible by mistake it can give me wrong knowledge.
No. Whenever, suppose there is an expert of mathematics, we cannot expect that the expert of mathematics will say by mistake 2 plus 2 is 5. Is it possible?
Because of
No.
human behavior.
If he or she is saying 2 plus 2 is 5 and he or she claims to be the expert of mathematics, then he or she is not an expert of mathematics. Whenever you are saying something, then there are 3 categories. One is the expert. Expert means whatever knowledge he or she is having is validated. We cannot expect that the expert is communicating the wrong knowledge. Otherwise, what will be the source? Because whenever you are using the internet, you are getting lot of information. Then you must have told that first verify whether this information is correct or not. Find out the source. Is it study this thing or not?
Okay.
Everything written on the internet is not correct. Whatever given in the Google you can just write down something and Google is giving you more than lakh pages. And you open one page and something is written onto that and you will say, okay, this is correct. Even you verify from some books, the programs written in that books is not correct. Okay?
Yes, ma'am. If I leave this topic, then second again, what you have given the whole scenario is only a proposal or you have put some solution also?
There are solutions. I am telling you there are number of machine translation systems, but they are not 100% accurate.
Okay, ma'am. So
one thing is, as a computer scientist or computer learner, we should understand what is the cause of the problem. It's very easy to say that the translation is not correct. Computer भी सही करके नहीं दे रहा. ना वो लेमैन भी कह सकता है. But आप computer science student को मालूम होना चाहिए why. What is the cause? Okay, that's why in most of the translation system, pre-editing and post-editing is done.
Ma'am, because natural language are informal, they are not formal. And
they are
to
formal.
avoid...
No, they are formal languages. They are very well syntactically placed and everything is formal in the natural language, but there are number of exceptions in natural language.
Yes, ma'am, so why I am telling, because whenever somebody put his language or put his word sentence, express himself, then it is not guaranteed that he will put a very formally.
There are number of things in natural language. I have not covered all this thing. One thing is a localization. Localization means the same word may be used in a different context in different local scenario. The meaning may be different. So there are number of issues. But main thing is that in case of the natural languages, there are formal methods, but there are list of exceptions. So we have to find out the method. For example, suppose I say there is one English sentence. It's a correct sentence. And Rajkumar is going to college. Rajkumar is not a word in the dictionary, but you can find it out. It's a proper noun. Why? Because it starts from capital R. But in case of Hindi, how you will find out that Rajkumar is proper noun? Okay? But because in Hindi language, you are not having any formal method to say that this word is proper noun. So we have certain methods. We can use statistical formulas, probabilities rather, by which we can say this word may be proper noun. But there may be in some cases it may not be. In some cases the output may be exact.
To say there are lots of improvement required here.
Yeah.
Okay, thank you.
Thank you so much, Sinha ma'am and Rishi sir. Before proceeding towards the oral presentation, I would like to invite Professor Hirayogi Ida sir, on the stage for the token of remembrance, and he has a flight to catch. So please on the stage. And I would also like to invite Ajay Sharma sir, convener Bicon 14, to present the token of remembrance. Thank you so much, Eva Sensei sir, for sharing your deep knowledge with us. With this note, I would like to hand over again the session to Punam Sharma ma'am.
Thank you, ma'am. Now let me have moved to the selected oral presentation by the young research scholars. First of all, I would like to invite Mr. Ashish Soni and Ms. Mansi Sharma to present their paper. I also request you to wind up your presentation within 10 minutes due to the lack of timing.
Good afternoon, all of you. I, Ashish Soni,
And I, Mansi Sharma,
here to present a paper on our topic traffic light control by image processing. Coming to introduction.
I think there is no need to introduce you all to traffic. It is a basic day-to-day routine of ours to travel to roads and getting trapped by the traffic lights. Traffic control is the need of the hour because today we come across headlines in daily newspapers like there is accident on that road and there is accident there. So for that many measures have been taken by the government. Many like using timer for each phase, electronic sensors, magnetic sensors, etc. And one method we are going to implement here.
As she told that there are many technologies for which we can control traffic, we can monitor the traffic. So there are timer for each phase, electronic sensors, magnetic loop detectors. But still there are some problems in these technologies. Discussing about probleming using timer, I would like to ask you a question that how many of you have ever been trapped in traffic at the traffic signal?
Please raise your hand, guys.
Raise your hands. Please, how many of you have ever been trapped in traffic? Please. I know all of you have been ever trapped in the traffic. I know it's a silly question, but the real question is how many of you have ever been trapped, even if the roads were empty? Anyone, if the roads were empty and still tracking,
And you are still waiting for the green light.
Yes. So this is the problem in each timer phase, because in the timer technology, you will have to wait for your turn to pass from the signal. Coming to the second technology, that is electronic sensors. It is an efficient technology, but its installation and its maintenance is very in the future, and still it's also inconvenient. Talking about some another problems like inefficient traffic monitoring, driver may have to wait for more time. A driver in hurry may break the signals and consequently result into the accident. And improper traffic controlling may lead to accidents and wastage of health and wealth.
Now you must be wondering about the solution to these problems. That we are going to discuss now. We are implementing the traffic control through image processing. Image processing is something which we are not familiar with. but we take images in our daily life. Every day you will click many pictures of yours. So this is what we are going to implement. It is this diagram will show the output or the working of the project. Like there in the first image, the real-time traffic scenario is shown, and there are, as you can see, there are many cars waiting for the signal to turn green. In the next image, the cars are shown as a processed image to the blocks, and how it is done we will be discussing here.
Now the feature analysis, how to implement it. We have implemented it in some phases. The first phase is image acquisition. The image acquisition part, we will take the picture of the traffic signal where the vehicles are still waiting for the green light. In the next part, we will take a picture without we will take the picture of the road without traffic, which will be kept as reference for the next images. And the third part, the picture which has been taken from the traffic signal that is in RGB will convert into gray conversion by the help of some techniques. And in the next part, a gamma correction is done to increase or to enhance the quality of the image which has been taken from the traffic signal. In the next part, edge detection techniques. We will use edge detection techniques to convert the real-time images into gray conversion, gray pictures, and which will help us to monitor the traffic.
Now coming to the first phase, that is image acquisition. He is told about that. In that we are going to take only the images. The major problem with that is the quality of the picture. If it is usable to take that picture as the captured image and the reference image as the quality measure. So for that we are implementing image enhancement, and for this we use power law transformation. The basic form of this is the equation that is presented here. S is equal to C R raised to the power gamma, where S is the output ray level and R is the input ray level, and C and gamma are the constants. This is the graph which have been developed by using various values of output ray level and input ray level at different values of gamma. Here we can show that y is equals to 1, that is the standard measure which brings the good quality picture. That the deflections are provided with values less than 1 and values greater than 1. Now I think according to the experiments that we have carried out, the values of fractions are not good, because if we can see in the first diagram, the first figure, that for the value of gamma as a fractional image, that is 0.2, the picture is like this. In this picture, there is more brightness, and we need a contrasting image. So for that, if we implement an full integer value like 4, it will give a contrasting image of black and white, which will be used as a good image.
And it will help in good image detection and traffic monitoring in efficient manner. Now, I would like to discuss about edge detection techniques. In this technique, as you can see in the image, it is an edge detected image used with the help of private edge detector. I would like to tell you something that in matching of image, we can use point, lines and edges. Since edges demarcates the difference between the two parts, as it is known that if there is an edge, then it will show that there are two distinct images which consist of image between them. And this is the main purpose of the edge detection method. In this part, the resulting binary image will consist of pixels for every point or every position. In short, it can give a bitmap for the image. The common algorithm used for edge detection is Sobel, Privet, and Laplacian operators. Now, image matching.
As told by Ashish, that we have captured two images. The first image will be the reference image of empty roads, and the next one will be the real-time scenario image. So in image matching, we match the reference image, which is converted into grey after RGB to grey conversion, with the real-time scenario image, and based on that, based on the percentage of matching, the timer will be set.
As you will see in the previous slide, it's a reference image and the other image is captured image. Since there is a difference between this, on the basis of the percentage of matching between them, we can conclude the results. The results consist of 4 cases. The first case, when the image matches only 10 to 50%. The second case, when image matches 50 to 70%. And the third case, when the image matches 70 to 90%. And the last one is when image matches 90 to 100%. Now considering case 1, when the image matches 10 to 50%, that means a lot of traffic is there. So we should turn on the green light for more time. We have taken it 60 seconds. In the next case, when the image matches 50 to 70%, then we can think that traffic is average on the lane. So we can decrease the time of green signal, that is 30 seconds.
Next, when the match results are 70 to 90%, it means that there is less traffic on the road. So there is no need to turn the green light on for more than 20 seconds. Next, when the matching results are 90 to 100%, then there is very less traffic, and for that there is no need to turn the green light on for more than 10 seconds.
Now coming to conclusions, our system is able to distinguish between the presence and absence of the vehicles in road images. That by checking the difference between the images, we can conclude, or we can say that whether there is no traffic, less traffic, average, or much higher traffic. The traffic light, we can signal the traffic light to go red if the road is empty, and we can signal the traffic light to go green if the road consists of vehicles or there is some traffic. These are the references that we have taken from the IEEE. Any queries? Any queries you have, you can ask.
This is really a good model, but I want to say there is a challenge. How will you identify the emergency vehicles like ambulance or firefighters?
So for that we are trying to implement GSM. In case of any ambulance or something, that ambulance will be having a software which will provide message, traffic signal, web camera on the database, and through that GSM signal the traffic light will be turned.
So in the further enhancement, we can also provide some GSM interface by which it will automatically track the ambulance, and in that case the traffic light will go green. In that case.
So you will track all the ambulance in the city?
No, sir, no. In the range of approx 100 meters or approx 50 meters, we will track the ambulance. If ambulance is coming, then we will turn on the green signal.
How will you track the ambulance? Some devices, tracking
of course,
devices?
There will be need of
The
devices.
ambulance will be having some device.
So you will put that tracking device on every ambulance?
So they can be implemented.
That is very much expensive.
Yes, sir. It is expensive, but sir, it's a case of emergency. It's not.
So we can find some other alternatives?
Yes.
Maybe, sir. We'll try.
Oh, thank you.
Any other question? Thank you, Ashit and Mansi, to share your knowledge about analysis and design of image processing.
Which tool you have used? Which tool you have used?
MATLAB.
For a gamma correction, what techniques you thought of, or what techniques you use?
So for gamma correction, these techniques were given by our guy, Mr. Manish Kumar Sharma. As we haven't worked on that, but the logic part is ours, and the implementation part is our guy, Mr. Manish Kumar Sharma, who is doing MTech from Jagannath.
Basically, I want to know which
Power law
algorithm was behind that.
transformation. The power law transformation for that. The power law transformation.
Are you sure?
Yes,
So with the help of the equation that S is equals to C R raised to power gamma, we can use the gamma correction.
Thank you.
Thank you.
Now I would like to invite Ms. Ashima Bhutna and Ms. Harshita Sharma to present their paper. Good afternoon, one and all present here. I, Ashima Bhutna, along with Harshita Sharma of 14'Oct College of Engineering, are here to present a paper on review paper on fast generation of digital holograms. I would like to thank Vyani Group of Colleges for giving us this opportunity. Now, first of all, we will include the holography. What is holography? Second one, physical principles of holography. Third one is holograms, types of holograms, and then abstract of survey paper, then experimental involved in it, and result, and lastly conclusion. First of all, what is holography? Holography is a technique which enables 3D images. 3D images means holograms. The 3D images formed in holography are holograms. Holograms are made up of two words, that is holos and brahmas. Holos means whole and brahma means messages. So holography is a technique of making 3D images, that is holograms. Now moving to the background of holography, Dennis Gatter is known as father of holography. He was awarded a Nobel Prize in 1971 for this invention and development of holographic method. Now what is hologram? Now we will understand what is hologram. Suppose there is an object in a room and from point source of light, that is reference beam, is incident on object beam. Object beam is a light, is a beam which has been generated from object. Now then at that point interference pattern is generated. Then we record that interference pattern and record on 2D or 3D medium. That recorded pattern is known as holograms. Now for making holograms we use photograph light waves. As we all know, for taking photograph of fast moving object, there is a problem created there. So for this we use a technique, that is interference. It is also a basic principle of generating a hologram. So principles of holograms are interference, which we have read earlier. Second one is diffraction. Diffraction occurs when a wavefront encounters an object, there occurs a diffraction, and these two principles, interference and diffraction, together makes an hologram. Now moving to the types of hologram. There are basically three types of hologram. First one is reflection, second one is transmission, and third one is hybrid. In reflection, these are the holograms which are lit from the front. That is, reflection of light takes place where we view it. For example, a photograph hang on a wall. The reflection of light takes place from the way we view it. So this is reflection hologram. Second one is transmission. Transmission hologram is the first one which was made in holograms. It is formed when object beam and reference beam together enter a same recording medium. That is transmission holograms. And third one is hybrid holograms. Hybrid holograms are used while taking floating objects, by capturing floating objects. Now this is an image of 2D interference pattern by 2 point sources of waves. Now recording. We take recording by making holograms. For recording purpose we use 4 techniques: laser, interference, diffraction and light intensity. Now I would like to invite Harshita for further proceedings.
Thank you, Ashima. Till now we have discussed about holography, the basic concepts of the holography and the hologram produced by it. We will now focus on the recording and how we can fastly generate these holograms. Till now we have utilized CPU, that is our, and now in faster generation we will use GPU, graphic processing unit. With we will apply CUDA technology, which is compute unified device. This will act parallelly, and with the help of this architecture we will able to generate allograms faster. GPU, CPU and CUDA, compute unified device architecture. that we are going to discuss. Now, we have developed our hologram. Hologram is generated with the help of a recording. With that, we need a display device. The display device contains a phase modulating element. When it strikes with a coherent light source, it gives us an image. But image is not only our objective. We need a hologram and its recording. For that, we need a quantization method. The noise should be controlled. And we need a projection techniques. For the projection techniques, we deploy a polarizer. The polarizers are used to control the waveforms, and with this we will optimize the noise. Noise are the extra data that when we try to click a hologram and record it, these are the noise we always want to eliminate it. Sometimes noises are also helpful for us. For example, if we want to reference an object where it is situated, that at that time we need a noise. Quantization of effect of holograms are also very important. Holographic projector principle was a projector that we have used. The projector was used by Edward Beckley. Edward Beckley produced the faster generating algorithms, and we are trying to trace them now. There were some problems that were faced that were twin barriers. The twin barriers were the real-time object and the problem that we have faced during recording of an hologram. The high-quality display. If we don't have a high-quality display, we cannot identify the object we are using. For that, the display should be of very high quality, and the human perception. When we see an object, we have some perception for it. For example, if we see a ball, we know it is a ball. Then similarly, there is a human perception accompanies with every object. This objective should be very clear with us. And these were the barriers that were not able to distinguish in holography. These were overcome by 2D image video recording techniques. The video recording techniques came in which there were the faster sensing, which overcome these defects and make it possible. Coming to the third part, the when we use CUDA architecture parallelly with GPU processing instead of CPU, and that we have used lasers, and laser made it very possible to record the holograms at a very faster rate. Here we can see there is a 3D object, and there is a digital hologram, the surface we are seeing. And this we can see there are 4 dots that are encircled within rectangle. In this where we have applied GPU and CUDA architecture. They both are helped to make this possible. This is a CGA competition which was given by Mr. Young in 2009 Conference of Faster Generation Techniques, in which we have used AI cos k pxa minus pxi whole square. This is a value when we multiply pixel pitch and pixel width with a digital hologram and summation it with a 3D object. This gives us the computation where we can actually record a single thread, the single thread for an object. These threads accompany later to make a whole of a 3D object. And as we see that we have pixels in photograph, we have threads which together compiles and make a pixel of a hologram. Now CGA is future for CUDA, in which we have used an AI cos theta 2 pi theta z plus theta h. The values of theta z are zi divided by lambda, this is the wavelength of the light, and zh. The experiment was conducted in which we used Stanford bunny rabbit 3D object, and its hologram was recorded. CPU that we used was Intel, GPU NVIDIA GeForce, OS Windows, RAM
calculated whose on the basis of in every the GDPR works. Research was conducted by Mr. Zeng. Sorry sir, there is no security measures involved in this. But the quality... No sir. Sorry sir, but we don't have any idea regarding the security of it. Thank you. Thanks a lot.
Thank you, Ashwin. It is very interesting to talk about analysis of first generation of digital holograms. So I feel it is a great session. At the end, I forward my sincere thanks to all of the speakers of this technical session. Thank you.
Thank you so much, ma'am, for chairing the session for us. With this note, I would like to invite Professor Shimoda Sensei, sir, to present the token of appreciation to Dr. O.P. Rishi, sir. Sir, please, could you please come on the stage to present the token? Thank you so much, Rishi sir, for sharing your knowledge with us. I would like to request Ashok to present a token of remembrance to Madhvi Sinha ma'am. Let's have a huge round of applause for Madhvi Sinha ma'am for her interactive session. Now proceeding towards our next technical session, that is pioneering technology in engineering, I would like to call upon the stage Gupta, Assistant Professor, Gyani Group of Colleges, as the third technical session, that is pioneering technologies and engineering. And for the speaker, I would like to invite Professor Ashok Bhaskar sir from IIT Delhi to deliver a lecture. Thank you so much, sir. Please be on the stage.
For inviting me to chair the third technical session. We have Professor Ashok and Bhaskar sir with us for the session. Sir, Ashok and Bhaskar
is professor in Department of Chemical Engineering at IIT New Delhi. His main research interest areas are in utilizing chemical engineering for cleaner technologies. His educational background consists of Masters in Engineering and PhD from Indian Institute of Sciences, Bangalore from year 1981 to 1987. He also did his postdoctoral at Indian Institute of Sciences, Bangalore. From year 1988 to 1989, he worked as scientific staff at LPD Gent, Belgium. From year 1996 till date, he is with Indian Institute of Technology, Delhi. From year 1990 to 1996, he was assistant professor at IIT Delhi and promoted as associate professor in year 1996 to 2006. And in year 2006, he is awarded as professor at Indian Institute of Technology. In today's talk, he will be discussing inflection points in the context of approach, recently created novel nanoparticles, and advancements in wet processing. I hereby invite Professor Sir for the talk.
I request all of you to kindly maintain the regular office symposium.
This is the second time I've been invited here, and I remember that each visit has been in some way interesting. The first time I addressed the gathering here was in 2012, when at the last moment I decided not to show any slide. And I had primarily come here to meet with the students, and during that visit I could not interact with any. This time it has been a different experience. At the outset I remembered that the theme of this particular session is going to be very different from what I have been doing, and I had to stretch my exposure and abilities to the limit to try and link it. But obviously there are commonalities, and that became the source of acceptance of this particular invitation. And the pleasant surprise has been that right in the morning I could interact with about 20 undergraduates, final year students. So that was a surprise. Alright. I have decided to talk about how potentially chemical engineering in its broadest sense could interface with applications in the IT sector, information technology. And let me start with a little joke about chemical engineering. And this comes from a professor of English who defined chemical engineers. Okay. A professor of English, now is it too loud? Define chemical engineer as a person who talks of engineering in front of chemists and talks of chemistry in front of engineers, and when both are present he talks of economics. I was probably in a similar situation, but I realized that the information technology, especially in the hardware sense of it, has kind of blown up to its limit. So much so that it is now materially limited. So a point has come when the information technology is poised as at a point which could be called as inflection point. So let's introspect a little bit about this inflection. There has been a consistent past record of the technology matching the demands and increasing demands through innovation. In mathematics, we understand an inflection point as where a second derivative changes the sign. In business, it means it's a time of massive change which you will see either large positive or negative results. We are going to talk about inflection point in context of approach, very little about some of the novel materials which are on the horizon, and the advancement in wet processing technology. Right here, let me put this in perspective. This is my contact point with information technology, or the way I can relate chemical engineering to the hardware part of information technology. These integrated circuits, or very large scale integration circuits, have been, in a sense, a direct application of chemical principles, chemical engineering principles. You know that in a small chip you have massive circuits, and every little connecting element has to get there in a precise fashion. And you do it by using optical techniques. You have kind of lithography technique. Let's say you think of having a connector in the shape of L but about micron size. And that's just one part of millions of such parts in the entire circuit. So what you do is you start with a slot which shines a beam of light in the shape of this L, but then uses an optical system to get a microscopic image. Now, chemical engineering connects with all materials. Obviously, in information technology, the demand on chemical engineering is very high. Chemical engineering is all about purification, separation. Here, the levels of purities which are required are extremely high, 10 to the power minus 12 parts per given billion parts, kind of. ppb level of purity is essential. So what is done is, the very basic material silicon itself is made in a special way. You can't take polycrystalline silicon, it has to be monocrystalline. And the economy of scale demands that you make large crystals. Now how are these crystals grown? Extremely pure silicon crystals, single crystals. They are traditionally made by what is known as Zucral-Stay crystal growth, in which you start with a seed crystal, dip it in a molten silicon, rotate it, gradually and then left it. As the seed crystal grows, you would be able to build up on that monocrystalline silicon, and people have grown very large crystals this way. After a large crystal is built, then it's mechanically converted into wafers by machining. And then you oxidize that, have a silicon dioxide layer, then on top of that you require special polymers. And these special polymers are optically sensitive. That is, if this L-shaped image, if it is exposed to UV, that portion will become soluble in certain solvent. So you basically remove that portion by dissolution upon shining light, and then you go on to deposit metal like copper or aluminum and create that first element. So over here we have these polymers are resists. They are photoresists. They could be positive or negative photoresists. The connection I have with this part of lithographic technique is from the conventional printing techniques of the year 1994. The European Union had equivalent figure of about 131,000 tons. And these VOCs are often carcinogenic. And air we breathe is a completely mixed reactor. Emissions from everywhere come there. Our target had been to develop next generation of printing inks, and these were lithographic offset printing inks, which would be completely free of the petroleum products. And the way we did that was by taking recourse to vegetable oils. And the vegetable oils, along with a specially prepared resin, which would be sensitive to change in pH, was the trick. So all inks actually contain oil, a resin, and a coloring matter, which may be pigment or a dye. And the resin, the polymer, was made sensitive to pH changes. So under acidic conditions, our ink would be hydrophobic, just like conventionally. Once on paper, it would become permanent. It won't contain anything which will be emitted. But when you wanted to wash it off the resin, contact it with a dilute alkaline solution and convert it completely into a water washable portion. And originally it was thought that this was a process of dissolution, but it turned out it was a process of emulsification. Today I do not think I have the time and you have the energy to go into the theoretical details of how it happens. But it is sufficient to tell you here this much, that the polymer has carboxylic acid groups, pendant carboxylic acid groups, which react with the sodium hydroxide and convert this resin into a polymeric soap, and that becomes emulsifying agent, which washes the ink containing the vegetable oil in the form of emulsion in water. Okay, so it is actually a similar thing which happens in the photoresist dissolution, and that's what attracted my attention. So we're going to talk a little bit about this weight processing technology. But I want to put the whole perspective as I understand as an outsider, and here is my attempt. So actually we want to describe the holistic response of industrial and academic innovators to the major challenges that are faced by IT technology sector today. Now, this is very well known. The semiconductor industry has the cyclic, it's a cyclic business of ups and downs. It is always rebounded with new technologies and next generation of electronic products. But the global demand is rising, and the cost of fueling the next generation technology is also growing very rapidly. If the semiconductor technology continues to be the way it is, then we can practically conclude that innovation will stall, new markets will stagnate, and the infrastructure for improving life will. But industry and technology challenges are not the only challenges for the industry. Industry's maturity and consolidation are also factors, and world economics, changing world economics and social factors outside industry are actually the main causes. So what happens within the industry are effects of, and the causes are outside. Now it's no longer sufficient to have the best technology, but it has to be best technology at the lowest cost. And this indicates that now every part of the food chain has to collaborate. Industries are started by having this control on product wafer metrology to calibrate lithography process and make corrections while maintaining process integrity. This has been the response of some people. Extreme lithography and other innovative lithography to mitigate the need for multiple patterning is also what is a possibility. Enlarging the wafer sizes to 450 millimeters may be a way forward. Today, IC has to be rephrased now as innovation and collaboration. You all aware of vertical integration model. Apple is an example of how vertical integration is done, and in the chemical companies, it is directed towards purchasing everything in the supply chain. What might be required now will be the horizontal integration, which incorporates fabrication process, metrology, and other manufacturing issues. The industry has to decide on a very important question, and that is whether the product diversity offered by Internet of Everything will replace the next big thing model of innovation. This time will tell. We've been talking about the healthcare. And it was bound to happen that progress in information technology will eventually gear to provide assistance to the healthcare. If you look at Internet of Healthy Things, you see that all sectors like pharma, diagnostics, medical devising, manufacturing, foundations, medical researchers, biotechnology companies, hospitals, all have to collaborate. And that's how in healthcare we see new business model coming up. Then application-specific programs are to be holistically shaped while holistically building on core CMOS process technology to identify new solutions for devices using ultra-low power. And there are many new ideas. I'm sure you have heard of recently advanced pacemakers which would draw upon the energy of heart muscles to recharge the batteries. Or you might have heard of the latest hybrid batteries which have been advanced, which combine the principles of solar cell and battery. The light is captured and stored in the form batteries. Collaborations to develop solutions, to explore new technologies, to shorten times to market, to bring new technology products to world are essential. So we are into an age where this equation is bound to be necessarily required. Among the novel materials, couple of materials stand out. I'm just going to mention those briefly. Tungsten disulfide is something which is current excitement in the industry. This is one of the most promising 2D materials. It has been proved that there are excitonic dark states which would eventually, these are the energy states in which a single photon can neither be absorbed or emitted, and these have been proven to be existing in two-dimensional material based on tungsten disulfide. Some of the properties are very large binding energy, the binding energy, large band gap, non-hygrogenic nature, that is with the moisture being reflected here. These materials are not only very important in understanding light-matter interaction arising from many body effect, but also for the electronic and optoelectronic devices such as ultra-compact LED sensors and transistors. This kind of large energy, binding energy of 0.7 electron volt could make an impact in future computing, quantum computing. Another material I would like to mention in passing is this HBN, or hexagonal boron nitride. Now, I'm sure you heard a lot of materials talk, and I'm sure we have experts here, but I think this is an interesting example I'm very fond of telling students. I think for over 100 years, graphite was known to chemists as a stack of single layers of carbon. But it was almost traditional to accept that it would be impossible to take a single plane out, a single layer out. And it was a pair of scientists at University of Manchester in the early years of 2000, and eventually they got a Nobel Prize for it. They demonstrated a single layer of carbon can be taken out, and that's the graphene tree. And the original experiments were ridiculously simple. All that Novoselov had done was take a cello tape, paste it on the graphite, take it off, then take off next layer from that tape and so on, and by doing it many times, eventually he reached just a two-dimensional carbon network or graphene. Here's an example of similar structure, what is called as white graphene, and that is your hexagonal boron nitride, which has potential to be of use in ultra-high frequency devices. Today morning we were talking about the RFID and the frequencies. There are going to be advances here through change of materials in electronic and photovoltaic sensors. And in the words of these Nobel laureates, this is a beautiful combination of classical laws of motion and quantum wave nature of electrons, which makes them flow through values. Coming to the last part, I want to keep this short and sweet. The wave processing techniques. Basically, there are, in the context of semiconductor processing, there are three steps. First is etching. Etching, whenever you talk of etching, you think of glass and HI. Okay? In this context, this is the taking of silicon dioxide. There are two approaches. What is done traditionally is we fix the time for etching and go for a certain acceptable overage. Okay? And that means there will be penalty in terms of cost of chemicals and of course time. So the other option is automatic adaptation of etch time so that you can take an accepted under etch. This is decomposing solutions, which is otherwise impossible to predict theoretically. So I have already explained with this now you can go up to 2% of uniformity in the etching process, and this has been demonstrated for substrates of 200 millimeters and 300 millimeters. Next is cleaning. The cleaning has to be done with this objective, the less is more. What it means is that diluted chemicals are better than concentrated solutions. Peroxide is one common chemical, and it is also a source for metal contamination. So what is done next is you have moved over to ozone. So you can take dilute chemical solutions and have concentrated ozone contact, and then you can achieve the cleaning. So that is the way to go for more efficient and cost-effective solution than peroxide. The last one is the resist stripping, which I talked about, and here there are many resists which require many chemicals, but most of them can be washed with just water and ozone. If there are different chemicals to be added, that can be tailor-made for given requirement, and strip rates of about 1 micron per minute has been possible. With sensitive materials like copper and some other resists, special chemicals are required, but here you go for full-scale automation. And this is my last slide for today for you. We sum up, it is now innovation and collaboration, and we need to think of green chemical engineering for evergreen information technology. Finally, all philosophy is summed up in these two words, sustain and abstain. We have to sustain the good parts and abstain for the bad ones. And Epictetus says that happiness and freedom begin with a clear understanding of one principle, that is under our control and others not. And we should be wise enough to know what that is. Thank you.
Thank you, sir, for such an influential and interesting talk. Now the session is open for the discussion.
Very good evening, sir. Actually, I don't have any question, but I'm so happy right now for the moments you shared with me and with all of us. that it appears I'm in dream and I don't want to write. So actually I want a presentation, I will observe it, I will see it, and I contact you time to time. So please, you can say grant me the permission so that I do it.
Sure. And for the students, this is now my outreach. IIT Delhi website, everybody can see. You know my name and you have my contact details here. In case you have any doubt, question, whatever it is about, and you think that I may be of help to you, please do write. You're welcome.
Thank you, sir. I will try for you.
Any other query? I'm very sure your work and words will prove to be very helpful for our students. Now, to continue the session, I would like to call Abhilasha Dani for her oral presentation. Due to time constraints, please Abhilasha, try to end your presentation within 10 minutes.
A warm evening to all of you. I am Abhilasha Rani, presenting myself to the topic KNN bias for quota categorization. Firstly, I would like to explain about data mining methodology. For example, I will start with Reliance Fresh. You all go to Reliance Fresh for shopping and for your home purpose. For example, you purchase a milk, half liter or 1 liter for 20 rupees per day. For 30 days, you purchase approximate 600 rupees. Yeah, your selling is approximate 600. After some days, with milk, the bread session or bread basket is available. You purchase the bread and the purchasing is near about 800 to 1000. The profit level in milk is approximate 1 to 2 rupees per packet. For example, 1 rupees is profit, then on 300 there will be profit of 3 rupees. Then again we will discuss about that. If bread is purchased, then the profit level is increased. After that I will discuss it in education data classification. For example, data mining. Data mining basically is a process of extracting meaningful patterns from a given data set by using artificial intelligence, data mining tools and artificial intelligence. This is basically used in business applications to improve business intelligence. After that, I will explain pre-processing and mining process. Firstly, we collect original data which is very large in size. Then we perform pre-processing. In pre-processing, we firstly perform cleaning of data, in which we transform the data in standard format, remove unwanted data, perform normalization techniques in which simplicity and complexity is improved. Then model is constructed, and finally meaningful patterns are extracted. With use of meaningful patterns, we can discover knowledge. For that, I can use the technique selective bias classifiers. It is a different classifying techniques in which we have very simple and fundamental classification, which is very simple, and we don't require any prior knowledge about knowledge discovery and bias in algorithm. For statistical setting, what is nearest neighbor and nearest classifier method? Basically, I would like to explain that example again, in which we conclude that with milk we can improve knowledge or improve our selling with bread. Then it is the nearest neighbor of milk. After that, we will discuss if with milk you want to purchase talcum powder, then the probability of purchasing is approximate 0.01. But with milk and bread, the probability is approximate 99%. Then this Bayesian algorithm works. I would like to explain the data classification in education institute. For example, अगर आप लोगों को ये कहा जाए कि आपके जो selection criteria होते हैं, for example, a company come here for selection or recruitment process, then he want to firstly explain all your details like what are your 10 percentage, 12 percentage, your education classification, your participation in conferences, etc. Else, I would like to include them in KNN classifier. I'll give them the sheet and KNN bias classifiers. In that, we select only those students who satisfied our criteria without processing them. Only 10, 15, 12 or whatever students are committed in this criteria, we select them. Then it is very easy process. After that, the government policy is quota categorization. SC, ST, OBC class is reserved for specific category. If we want to include your forms and process your forms, you have to fill many forms like your name, mother name, occupation, your father, etc. etc. After that, if we use KNN bias classifier, we just put your entries in that and we get final result that who are selected for the reservation criterion, who are general criteria. After that, the processing becomes very easy and errors probability are very much less. I explained the aim of my paper is to highlight performance of employing KNN biases in education data classification. Because education is the industry in which data is increased year by year. For example, if Rajasthan University data is concluded, there are approximate 77 colleges are affiliated with Rajasthan University in Jaipur only. Approximate 10,000 students are enrolled per year. With one student, approximate 55 data are collected. So you suggest or just imagine that what kind of data, what huge amount of data we have to collect. In that, we have to find out which students are selected and which students are not selected. Then this Bayesian algorithm can work and this gives result and final answer that those are the students which are selected for the criteria or not. For example, in this paper, I include 152 students data for Center of Converging Technology, which is Autonomous Institution of University of Rajasthan for BTech and MTech students. With every student, I collect 42 criteria like father name, mother name. They are normal criteria. The advanced criteria level are you are day scholar or hostler, you are education emitted or not, you are attending conferences or not, and finally conclude that you are eligible or not. Just by using that data, I can perform mining algorithm and produce the final result. As you are caste and subcaste. For example, if you are Hindu, then Hindu again is have subcaste like Sharmas, Vyas and so on. Then we have to classify according to your caste levels. Government says SC, ST, OBC are reservation category. My paper support that if ST, SC and OBC have reservation category in our education system, then the percentage of education classification has increased. For example, a SC or ST student have percentage in 10th, for example 65, and if he admitted in MTech classification, then their percentage will be approximate 80, 85, 86. For my data classification, I collected that data set in which I collect 42 entries of each and every student and perform normalization technique. Normalization is a process of minimizing the redundancy and complexity of data. After combining them, I divide them into three categories: good student, average student and poor students. And the result shows here that most of the SC, ST and OBC students their knowledge and improve their category. For example, if they are poor, then go to the average step, and if they are average, then go to the good step. And the data is increased day by day. Next, evaluation of test results. KNN biases produce 84.6154% result. There are many other classifiers available like Naive bias, STM bias, which are more accurate than that. But KNN bias is very simplest method. Firstly, I would like to explain this method, and the error rate of KNN bias is very much reduced. Approximate rate is very much less. For example, mean absolute error is 0.262 only. After that, my conclusion of that paper is by using different Bayesian algorithms, we can use different pattern recognition system. For example, currently you all are using smartphones. On smartphones for security, firstly you are using pattern recognition system. In pattern recognition system, if a machine wants to identify the pattern, what is the pattern? After 5 times you apply wrong pattern, then the pattern is automatically locked or your phone is locked. After some time period, you try to the pattern. But if I want to access your pattern, then I can use this Bayesian algorithm by applying then its nearest pixel, calculate what is the probability of pixels and compute your pattern. For example, other area of data mining is your artificial intelligence. As many teachers discuss here, artificial intelligence is a growing interest of data mining. With data mining, we can applicable them in rich areas and produce many meaningful results. For mass estimation, we can include many more different Bayesian algorithms for more proper results. I can use many references. Now finally, thank yous, and if you like to question anything,
thank you, Abhilasha. Any queries? Okay. Thank you, Abhilasha. Next, I would like to call Ms. Harshita for her oral presentation. Sorry, it's Mr. Harshita Prakash for her oral presentation.
Good afternoon, everyone. I am Harshit Prakash of St. Xavier College. Is here to present my paper review on cloud computing enhancing Indian education. With the help of my LCD department, Institute Therapy, I have written this paper on giving the benefits of the cloud computing in the Indian education system. Cloud computing system offers many new technology which is employed in many sectors and can be applied in furthermore in education system. The current scenario of the cloud is rapidly growing and can help education system to emphasize, it can help in emphasizing in the core activities and guarantee smooth operation workings. Secondly, it can help to increase the quality of the teaching courses guaranteed. Second, with the help of cloud education system, many education companies or education departments can use different kinds of services that are provided by the cloud, like SaaS, PaaS, and IaaS based combination for marketing without directly investing in its hardware or any other infrastructures. The three basic services that are mostly provided by cloud education system in India are IaaS, SaaS, and PaaS. IaaS stands for Infrastructure as a Services. In this services, hardware services and computation powers are provided. All the computation powers and secondary resources can be bought or can be taken from a lease from a company and can help them to generate IaaS and PaaS can be used by students, faculties, administrators, and any other secondary. SaaS software services can be used by students and faculty, administrative department for uploading data directly to the internet or their own cloud services. Second, IaaS to develop new cloud services, maintain them, and help other education systems to provide their services. Third, PaaS can be used by execution or for database and development services. The benefits of the cloud in Indian education systems are personalized learning. Students which have access to directly to internet by any handheld device or any internet connected device can use cloud for their education purposes, can by themselves could read the data and other education notes from it. Second, it reduces the cost. By reducing the cost of printing on the paper and reducing the time taken for emphasizing or distributing the educational forms. Second, accessibility. Cloud education can be accessible by 24/7 through the internet for everyone at every other places. Second, there is no need of new infrastructure. As we know, the cloud services are currently provided by many companies for free and paid services also. Second, it helps us go green by reducing the carbon emission footprints of the traditional education approach. Second, it is user friendly, allowing multiple users to use it and relatively easier for everyone who use the internet. Second, it plays standardized contents. Let's suppose if a teacher uploads study material on a cloud, it can be visible for all at anywhere at any place. So the teacher does not have to worry about different study materials for different places. Every student can see a single study material and can help to create a standard content. Second, it's collaborative. Students and teachers can interact on cloud with each other. Ability to roll new courses. Directly we can upload new courses on cloud and everyone can access it. Third, low cost in education and scalability. Conclusion. The cloud has a very substantial scope in the Indian education system and can help the education system to improve its abilities and help them to increase the growth of Indian education by rapidly and increasing the student excellency in education offered to them. Thank you.
Any queries?
You told about the benefits, then why people are not using it? Institutes don't use it. Why?
Most of the people don't know about it. There is not a lot of development or research on it. The institute should apply it. And secondly, there are lots of misconception thinking about it, like don't it, or it would be hard to difficult to access or interpret.
You said that faculty, students and everyone can load their papers and all in that. Is it secure?
If you could buy paid services, then it could be secured. For free, that depends on the service provider or which cloud service provider are you using.
Thank you. Thank you, sir. Now, I request Ekta ma'am to take the session.
Well, it was all about today's symposium. So first of all, I would like to know the feedback. Anyone of the outside the participants, we would like to know how do you feel about the symposium and any other suggestion you would like to give or whatever you feel is coming in behind you can tell. Can you please have the mic, volunteers? Can you have the mic? Any other student? The students those are sitting with a sky blue t-shirt, shirts I think. You would like to share something? Yes. Ma'am, could you please give the mic?
share myself among you. Before I do it, first of all, really I will thank all the bodies here who organized and presented here among us and all who have attended here. Really, I feel very proud to come here, but however, I'd like to say, not to suggest, it is my request only that the representative who come here to represent himself or herself should be filtered, first of all, so that he or she should not be dishonored in the respect of students. I observe it. I have very keen interest and respect to teachers. And when I feel in the regard of them, then I break in myself. So nothing else, all were fine, but it should be amended. Thank you.
We do agree, sir. We appreciate your suggestion. Anyone else who would like to share anything about the conference? Any of the BGC students would like to share? Neha, you would like to share something? Please come on. It was really very informative, and also every query was really great. I have been to Japan and I know that yes, there is a great scope of development there, and as well as in India, we can copy something as well as we can learn something from Japan. And from the aspect of information technology, India is rather growing very fast, and to grow more, we need to learn from all the Asian countries as well as Western countries. So thanks to all of you that you maintain the decorum of the auditorium and you all participated in our Vicon. Thank you so much. I will request Bhaskar sir to please guide them for their future with a good note. Thanks, sir. Please, if you can guide them for the future.
I don't know. I spent about 1 hour with the chemical undergraduates today, and this is a mixed group. So the first and foremost is, of course, work very hard, as hard as you can, because there is no substitute to hard work. Number 2 is often forgotten that you have to think a lot. Third is that they are going to be breaks. You see, you have got exams, you got cultural festivals and so on. So it is bound to happen that whatever you are studying regularly, that will be interrupted. You have to remember one word, that is called restart. It is very important. Stopping happens automatically. Restarting requires a reminder. So have clear goals, work very hard, and if possible, love your work, nothing short of it. If you follow these words, just 3-4 words, I am sure that there are no opportunities which you would not be able to make best. All the best.
Thank you so much, sir. Not a single event can be performed without a leader. It was a great opportunity for all teammates to perform under the guidance of Mr. Ajay Sharma, convener by Con 14, Mr. Aritificial, co-convener. Their efforts are marvelous and they marked a new dimension in the field of IT and engineering. A very special thanks to Secretary by Con 14, Anupama Singh ma'am. We wish that all of you will sharpen your knowledge on that and guide us for our future. I would like to invite on this note Ajay Sharma sir to convey his thanks to us. To all of you, all the participants who made this event possible.
Good evening, students. and delegates. I want to say something regarding this symposium. First of all, our most valued invited guests and delegates, it's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Jayani Girls College and the entire organizing committee, extend a very heartily vote of thanks to all speakers for gracing this important event and sharing their research and opinion today. I also wish to express my gratitude to JEST for supporting our conference. I also extend my thanks to our sponsors, technical staff and other financial supporting bodies. And finally, I would like to give my sincere thanks to my motivated and dedicated staff members, student council committee members and students. I will request our speakers and staff members to come on stage for a group photograph with Bhaskar sir. Please.
I would request Sanjay sir to be on the stage, please. I would request Ashok Bhaskar sir to be on the stage. Sanjay sir, we would like to request you to present a token of remembrance to Ashok Bhaskar sir. Let's have a very huge round of applause for Bhaskar sir. Then I request both of you to remain on the stage, please. Now the most important and awaited thing, the results. You all are waiting for results? Yes? Any guesses for the second position from the oral presentations? Any guesses? Okay, you all are expecting at the first position. So I would like to ask Sanjay sir to please announce the first and second winners.
So the second rank or winner is Abhilasha Dangi.
Let's give a huge round of applause for her efforts and her hard work.
So Abhilasha in the name itself shows whenever we wish, whenever we desire, we are inventing someone, we are getting someone. So Abhilasha, your name itself shows you may be a good inventor. You may achieve something in your life. Thank you very much.
Let's have a huge round of applause for Abhilasha. Abhilasha, we wish you a very good future ahead in the field of research and innovation. Thank you so much, sir.
Once again, I would like to remind, when we can get something, when we achieve something, when we appreciate, when we will be appreciated, when we appreciate others, So big round of applause for Abhinasha, because whenever we appreciate others, we are getting something. Because it's a neutral law, whatever we give, we will get accordingly. हम जो देते हैं वही हमको मिलता है. तो अगर हम सब लोग अगर अच्छाई को बढ़ा देंगे, अच्छाइयों की तारीफ कर Great. Purnima means positivity. Ashish means blessing, and Mansi means winner of मन, जो मन की हो, जो passionate हो, जो मन का जो समझ में आए वैसा करती हो और मन को नियंत्रण में भी रखती हो. Ashish and Mansi, congratulations. Thank you very much for that.
Thank you so much, sir. Now, here I would like to invite Anupama Singh ma'am, Secretary Biocon 14, to say a few words for the conference.
Let's big round of applause for Anupama Singh making best efforts, organizing a full show of 6 days, continuously working very hard for last 2 months.
Hello everybody. Well, today this is a very big event for us. From last so many years, from last 8 years, we are organizing international conference, and I feel proud to say that from last 8 years, I am here. I am the witness of this conference, and every year we are doing this positively. And we try to make our best to make this seminar or symposium to be in India. And definitely we will achieve our target in the coming years. And nowadays we are organizing 5-day conference and specialized in each and every field. And I feel proud to see you all to be here, to be the part of the symposium. And I just want to say thank you to everybody, thank you to my staff members, to my directors, to give me the chance to organize this type of symposium. Well, I used to keep behind the curtain to myself. I don't feel so much confident to come on stage every time, but still I just want to give thanks to people who have supported me, just like my directors, my faculty members, my student council members, students, and all the staff members. Thank you once again.
Thank you, ma'am. As the name itself shows, Anupama means unique, means adbhut, means different. So you are different and you are making this event very beautiful, very good. Once again, I would like to say thank you and congratulations, because this is very great event and well-planned event. So in future, I would like to be regularly associated with the institution, regularly associated with this symposium. Thank you. Thank you.
Thank you everyone for being a part of this event. So can we have a group photograph with all of us from other institutions?
Yeah, it's
I invite all the students, those are from the other institutions, to please click a picture with us for our memories. Let's have a huge round of applause for all those who have come from Purnima.
Today I am reading the newspaper. The interview is interview of Amir Khan. Day before yesterday, probably yesterday he is in Jaipur. But yesterday I was in